Hello again. In this video, I'm going to go over this homework problem from 4.6. So in this problem, it says approximate the change in the volume of a sphere when its radius changes from 20 feet to 20.1 feet. And of course, the volume of a sphere is 4/3 pi r cubed. Now, when they say to approximate the change in the volume of the sphere, I think to be more specific, they're asking us to find the differential change in the volume instead of the exact change in the volume. So let me show you how we can do that. So we're going to use this formula for the differential change in y. The differential change in y is the same as f prime of x times the differential change in x. But we're going to change the variables here because in our problem, our input variable is actually r instead of x, and our output variable is v instead of y. And we know that because this is our function that we're working with. R is the input variable and v is the output variable. So if you rewrite this equation here in terms of the new input variable and the new output variable, it would look like this. The x becomes an r, and then the y becomes a v. Okay, just because your input variable has changed to r and your output variable has changed to a v. Okay, so let's apply this to this formula and find the differential change in the volume. Okay, when you do this, there's a few things you need to figure out first. The first thing you need is you do need to find v of r, okay? And in this case, that's the volume of the sphere. And then after you find that function, we're going to find the derivative of it, so v prime of r. Okay, well, to find the derivative of this, the 4/3 pi, that's just a constant. So to find this derivative, you can just find the derivative of r cubed and then multiply it by that constant. And of course, the derivative of r cubed is 3r squared using the power rule. Okay, so then that just gets multiplied by the constant which sits in front. And then notice the 3's cancel here. And so you're just left with 4 pi r squared. So that's your v prime of r. Okay. So there's actually three things you should probably determine up front. The first one is what function you're going to work with. Okay, in this case, v of r is the volume of the sphere, or the formula for the volume of the sphere. Now r is the next thing you should decide. Now r is the r that you start with. So the radius started at 20 and then changed to 20.1. So the r value is the one that the initial r value. So initially it started off at 20. Okay, so r in this case, we're starting off at 20. That's your initial value. Okay, and then the next thing you should probably decide is what your change in r is, your dr. Okay, in this case, we're changing it by 0.1 because we ended up at 20.1. That 20.1 was the final radius, and so it changed by 0.1. Okay. And then once you've done that, all you have to do now is just go plug everything back into this formula to find the differential change in v. Okay, so we need to take the derivative of v and evaluate that at r. So v prime at 20, because r is 20 here, and then times the differential change in r, which is 0.1. Okay, and then let's just go find v prime of 20. So you just plug a 20 into here. And so you get 4 pi times 20 squared. Okay. And then 20 squared is just 400. And if you multiply 4 by 400, of course, you get 1600. So it's just 1600 pi. And then you multiply that by the 0.1. Okay, so I'm just going to calculate this on the calculator. So 1600 times pi, and pi is a second button. So you have to press this second button here, and then the pi is right there. So second pi, and then times 0.1. Okay, so it's about 502.65. And that's an approximation because I've rounded it off. So let's just write that as approximately. Okay, and then let's compare that to the answer in MyMathLab. So 502.65, right? Rounded to the nearest hundredth. Now, this is called the differential change in the volume. And this is a good approximation for the exact change in the volume, as long as this dr is not that big. Now, the larger dr is, the more error there will be in the approximation. Now, the exact change in the volume, which they didn't ask for, but I would like to mention just for a moment, if you wanted to find the exact change in the volume, the symbol we use for the exact change in the volume is this delta. So delta V, that's called the exact change in the volume. Well, that would just be the volume of the sphere at 20.1 feet. And of course, that's just 4 pi or 4 pi over 3 times r cubed, which would be 20.1 cubed, right? This would be the volume of the sphere when the radius is 20.1. And if you subtract off the volume of the sphere when the radius is 20, so 4 pi over 3 times 20 cubed, right? That would be the volume of the sphere when r is 20. Then the difference between these two numbers, of course, would be the exact change in the volume. Okay, so I'm just going to calculate that on the calculator, even though they didn't ask for this, just to give us a comparison. In fact, to make it a little bit easier, we can actually factor out this 4 pi over 3 since it appears in both. And so if you factor that out, of course, you're left with 20.1 cubed minus 20 cubed. So I'm going to calculate what that is and then just multiply it by 4 pi over 3. Okay, 20.1 cubed minus 20 cubed. And that gives you this number. And then let's just multiply that by 4 pi divided by 3. And you can see that this is the exact change in the volume. It's about 505.17. Okay, so it's, it's off by about 3 units here, roughly. Okay, and again, as long as dr is small, the smaller dr is, the better the approximation would be. Okay, so I hope you found this video helpful. If you get a chance, you can watch some of my other videos from the homework. And until then, bye-bye.